I didn't check, but I can
Okay.
look.
It's all right. You don't have to, but just remember that those videos are there. Okay. So I
Okay.
do that so that I can go, because I know we only have a half hour usually, and that just allows me, it gives me the freedom to kind of go fast and
Mhm.
let you go back and watch it later if you want. But
Mhm.
slow me down if I'm going too fast. Okay. So this problem is asking you probably to solve for x, right?
Yeah.
And you can use your calculator. Now, the reason I know you can use your calculator is because this is not a multiple of 15. 245 is not a multiple of 15. Actually, it might be a multiple of 15. I'm not sure. Let's see if 245 divided by 15. I'm not sure off the top of my head. 5, 9. No, it's not, because if it was a multiple of 15, this would be divisible by 3, and it's not divisible by 3 because one of the rule divisibility tests for 3 is that if you add the digits together, 5 plus 4 plus 2 is 11, and 11 isn't divisible by 3, so neither is this. That test works for the numbers 3 and 9.
Okay.
I don't know if you've ever learned that. So I know
Yes.
that this isn't divisible by 15, and it really wouldn't matter so much if it was divisible by 15. It would matter if it was a power of 15. And I know it certainly isn't a power of 15, which just means I can't solve this without using logarithms. So logarithms allow you to solve equations where you have variables in the exponent. That's the point of a logarithm. Not the point, in my mind, that's the point of logarithms. Okay?
Okay.
So how do I solve this problem? Well, first of all, there's a couple ways you can do it, and I'm going to do it both ways so that you can see two different ways to think about it. With logarithms, there's always more than one way to solve problems. So this first way I'm going to do, and I'm going to use logs. I'm going to take the log of both sides. And that log, by the way, in your calculator, what log button is that? What does that mean, log? Do you know? Do you know what the base is of that? Any idea? Are you with me still, Maura? I can't hear you. I think I may have lost you. Are you there? Can you hear me? I can't hear you. You there?
Hello.
Oh, there you go. You're back?
Sorry, my Wi-Fi went out.
Oh, that's all right. I did. Yeah, I asked you a question and you didn't answer, so I figured something happened. All right, so back to what I was doing. So I'm going to do this problem two ways. Okay.
Okay.
You can see the black was the original problem, and then the red is what I did to it. I'm taking the log of both sides. It's kind of like taking the square root, right? If you had x squared equals 8, how do you solve for x? You have to undo squaring, and how do you undo squaring?
Square root.
You take the square root. The square root is the inverse of squaring. So your answer is going to be plus or minus square root of 8, right? Whatever that number is. Okay, which means it's the number that multiplied by itself gives you 8. That's the square root of 8. And there's plus or minus because remember there's a positive and a negative root. So what was the radical, this radical, what was the root, the index of this radical right here? They don't write it. If they don't write it, what is it? What does square root mean?
Oh, sorry. It got out again.
Oh, is it, are you not able to hear me very well?
Yeah. Can I rejoin on my hotspot real quick?
Yeah. Are you sure it's your Wi-Fi?
Yeah, my Wi-Fi keeps going out.
Oh, okay. Yeah, go ahead.
Okay.
All right, you're back?
Yeah, that should work better.
Okay. So back to what I was saying. So the whole point, remember what I'm showing this as an example. Mathematics introduces operations that allow you to solve problems. They're called inverse operations. You learned how to add when you were in first grade. You learned how to subtract after that because it undoes adding. You learn how to multiply when you were in third grade. You learn how to divide after that because dividing is the inverse of multiplying. Then you learn about squaring things. Square roots are the inverse of squaring. It allows you to solve for x. See that? See how I got x by itself?
Mm-hmm.
So now we're doing the same thing. When we have a variable in the exponent, the way to undo an exponent is by taking the log of both sides. Here's what taking the log does for you. And by the way, the log, if I don't write a number under here, an index, it means it's base 10. Similar to when if I don't write an index with this root symbol, it's a square root. You assume it's a 2. So for this log, you assume it's a 10. Okay, unless I wrote a different number down here. You with me still, Maura?
Yep.
Okay. So the reason we do this is because one of the properties of logs says that I can take the exponent now and move it to the front and make it a factor instead of an exponent. So taking the log of both sides allows you to bring that exponent down and turn it into a factor. Okay?
Okay.
Now this is just a number. The log of 15 is just a number. I'll show you. If I do the log of 15, it's 1.176. You might think, well, what the heck does that number represent? Well, if I raise 10 power, if I raise 10 to the power of that answer right there, I'm going to get 15 back. That's exactly what a logarithm is. It says 10 to what power equals 15. This is the number that when you raise the base, which is 10, to that number, you get 15.
Okay.
Got it? So this is just a number. That's all. So is this. This is just a number. So I can solve for x by dividing both sides by this, right?
Mm-hmm.
So that would be, so 2x minus 3 equals the log of 245 divided by the log of 15, which remember, that's just a number. This is just some number divided by some other number. In fact, I'll do it in my calculator over here. But be careful when you do it. You can't divide these two things. That's not the same thing. You have to type in log of 245 divided by log of 15.
Okay.
See how it got parentheses in there? So that number is this. Okay. So I've got 2x minus 3 equals 2.0314. I'll write it 4 decimal places. Now, how do I get x by itself?
Move the 3 over.
Good. By doing what?
Adding the 3.
Good. So this is 5.0314. And now what?
Dividing it by 2.
Good. So I'll do this on my calculator over here. I'm going to add 3, and then I'm going to divide it by 2. So my answer is 2.5157, etc. Okay, now watch this. You're going to learn something new and you're going to be very happy I taught it to you. You ready? I'm going to teach you one of the best hacks of all time with your calculator. It's not really a hack. It's just a way to check your answer. I'm going to store this answer. You see that little store button down there on my calculator? The STO? See what I'm pointing to?
Yeah.
You see what I'm pointing to down there?
Yeah.
Okay, that button lets you store something in memory. So I'm going to hit store. So it's taking that answer and I'm going to store that for the letter X and hit enter. So every time every time I type in x with something, it's going to substitute that number in there.
Mm.
See that? So if I
Yeah.
wrote 10x, it's going to give me 25.15, blah, blah, blah. It's multiplying 10 times x. So now what I'm going to do, look back at my problem. I'm going to punch this into my calculator. And what should I get when I punch that into my calculator? When I punch that with x?
245.
I should get 245 because I'm basically plugging this back into there, right? So watch this. 15 to the 2x minus 3 and hit enter. And that means I did it right. Okay? Make sense?
Yeah.
Are you clapping? Are you crying because you're so happy you learned that? That's probably it. You're choked up a little bit. That's fine. I get that a lot. Okay. I'm going to do this a different way now.
Okay.
Do this with the equivalence. I don't know if your teacher calls it that, but that's what I usually hear it called. The equivalence says this. If you've got b to the x equals y, that is the equivalent. That exponential equation is the equivalent of log base b of y equals x. Have you seen this before?
Yeah.
Yeah, you've seen this a lot. So we're going to do it this way instead. Because I'm going to show you there's two ways you could have done this problem. So there's my exponential, right? And I want to turn that into a log by doing what? Tell me what to write. Log base what?
So log 15.
Log base 15. Good. Log base 15 of what?
245.
245 equals what?
2x minus 3.
2x minus 3. Now, this is just a different way of solving this equation. It's essentially the same equation. I actually prefer to do it this way, but this is the way that some people prefer to do it, and it's good to know both ways. Now, this right here, some calculators can't do this. Some calculators can't do log base 15. Mine happens to be able to do it. And the way I do it is you have to go to math, and you have to go to log base. And then I type in 15, and then I type in 245. And it's going to, when I hit enter, watch what it's going to give me. There's that number, Ben, 2.03, right? Remember that?
Yeah.
Why? Because that's essentially, this is essentially this. These two things are the same thing. Okay? So, and then you just add 3 to it. So remember, so that was 2.0314 equals 2x minus 3. So I'm adding 3 to it. So 5.0314 equals 2x, and divide both sides by 2, and you get x equals 2.5157, just like we did on the other side. Okay?
Okay.
Good? All right, moving on. Solve the equation and check your answer. So now we have a logarithm. We want to try to solve it. Solve this equation. Well, now we have to convert this back into an exponential. So let's remember our equivalence. Our equivalence said if I have the log base something of x equals y, that's the same as saying b to the y equals x. Now, ln, do you remember what ln is?
It's e.
Log base e, very good. That's what ln means. It means log base e. So I'm going to, so if I convert this, what's the base?
4x plus 7.
What's the base of this equation?
Oh, ln.
What's the base of ln?
Oh, e.
E. So I write e to the what?
Yeah.
Look at what I do. I go b to that power. This is how I like to do it. Equals this. Draw a circle like that. B to the y equals x. B to the y equals x. The base is always the base.
E to the
So e to the what?
e to the 4,
Good. Equals.
4x plus 7.
There you go. Now, e to the 4 is just a number. Remember, e is actually just the number. I'll show you e. That's e. It's kind of like pi. It's a special number. So e to the 4th is just that number to the 4th power, which is that number. Got it? So this is just 54.598, I'll say. 598 equals 4x plus 7. Now what? Remember, I'm trying to solve for x.
Subtract 7.
Good. So I'm going to do that on my calculator. Whoops. Let's go back and get that. Didn't. Subtract 7. And there's that number. So 47.598 equals 4x. Now what?
Divide by 4.
Divide by 4. My gosh, why is that not working? Divide by 4. Why is it not giving me answer? Divide by 4. It's like it's not keeping that answer in there for me. So x equals 11 point. I'm just going to write 11.9. See how it's so close to 11.9. And again, I can check my answer. Watch, I'm going to store it for x. Store that for x and hit enter. And now I'm going to type in natural log of 4x plus 7. And what should I get when I hit enter right now?
4.
And I do. Good job. Good. Moving along. I'm going to go a little bit faster, okay?
Okay.
So that we don't run out of time, because I know there's a lot with this. I know there's lots of questions you probably have, but I want to try to get through them. So for this one, again, we're going to use the equivalence. Remember what the equivalence is. The log base b of y equals x is the same as b to the, whoops, I wrote that the other way, didn't I? Is the same as b to the y equals x.
Okay.
Is that how I wrote it before? I don't remember. Doesn't really matter. It's the same. So what do? I rewrite this. That power equals this. So 2 to the 3rd equals x squared minus 7x. What's 2 to the 3rd?
8.
8 equals x squared minus 7x. How good are you with quadratics?
Not great.
Okay. So to solve quadratics, I have to set it equal to 0 first. So I moved 8 over. And now I want to factor. How good are you at factoring?
That's the part I don't really get. Like,
all right, so I can't teach you factoring in 10 minutes, but I'll show it to you, and then I'll show you another way you could do it. So the way you factor it, what multiplies to -8 and adds to -7? Well, that's -8 and +1. -8 times +1 multiplies to -8 and adds to -7. So it's -8 and +1. How can I check it? I go boom, boom. Oh yeah, look, there's -8x and there's +1x. And there's x squared and there's -8. So when I put it all together, I get x squared minus 7x minus 8. So that worked. And why do I want to factor? Well, now I can use the zero product property, which says, hey, if something times something else equals 0, either this has to be 0 or that has to be 0. That's the only way to get that to equal 0. In fact, it will always equal 0 if one of those two factors equals 0. So if that equals 0, or if that equals 0, this product is going to equal 0 if and only one of these two equals 0. If and only if, I should say. So this is x equals 8, and this is x equals -1. Now, here's the thing with these. These aren't necessarily both correct. You have to plug it in and find out if they both work. Because remember, in logarithms, you're not allowed to take the logarithm of a non-positive number. This has to be greater than 0. So plug 8 back in here. What do you get? 8 squared is?
64.
64 minus 8 times 7.
42.
That's 8. Yep, and that works. Right? Now plug in -1. What's -1 squared?
1.
+1. What's -1 times -7?
Negative or positive 7.
+7. What's 1 plus 7?
8.
It works. That's still a positive number, so they both work. So both of these are solutions. And
Yeah.
again, you can check your answer. You can type in negative. If you're like, I don't know if -1 works, that doesn't seem right. Store it for X and check it. Type in log base 2. So go to math. Your calculator might be different. Log base 2 of X squared minus 7X and hit enter. And there you go, is equal to 3. It worked. Okay, good. Questions about that?
Nope.
All right. You invest this much in account, buy this much, blah, 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 double, blah, blah, blah. All right. So here's your interest, compounding interest continuously formula. It's PERT. The amount you have in your bank is equal to the principal times e to the RT, where P is your principal, the original amount you put in. Principal. R is your yearly, is your rate, your annual rate, and T is the number of years.
Mm-hmm.
Okay, so you invest this much, that's your P, into account in this year, and by this year, your account has doubled. Hold on, the bank you go to has the interest compounded continuously. Okay, so they're telling you that it's continuously, which means we're using this formula, right? What is the interest rate? So we have to solve for R. So we know that it doubled in how many years? What's the time?
6.
It's 6. Very good. T equals 6 years. So we know the amount is double. Show you a trick. I don't actually have to worry about what the P, they didn't even have to tell me the P. That didn't matter. Since the amount doubled, I know that A divided by P, the amount divided by the original, was just 2. So all I really need to write is 2 equals E to the RT. Now, did I say that too fast? Do you need me to explain that?
No, that makes sense.
That makes sense? If you want, you can just double 575. Whoops. 575 times 2, you can just double it, 1150, and you can set it up like this. 1150 equals 575 times e to the RT. But what you're going to do is divide this by this, and you're going to get this equation.
Okay.
That makes sense? So now, remember, we know T. What is T?
6.
So it's 6R. And hey, what was the trick I taught you when you're trying to solve an equation that has a variable in the exponent? What was the trick I taught you? Remember, that was the first thing I taught you? Well, you take the log of both sides, right?
Okay.
Remember that trick?
Yeah.
Or if you want, you can do the equivalence and you can convert it. It doesn't matter. You can do it either way. So this, if you want to do the equivalence, you would say the log base E of 2 equals 6R. You could do it like that, or you could take the, and by the way, I'm going to take the natural log of both sides, not the log base 10. Because what's the base of the natural log?
E.
What's the base of this? It's E, and we have an E involved in this. So when I do this, what's going to happen when I take this 6R down front? It's going to be 6R times the ln of E equals the ln of 2. And what's the ln of E? Remember that one formula, log base B of B always equals 1. Because B to the 1 equals B. So what's the base here? It's E. So what's the ln of E? It's just 1. So that just goes away. That just turns into 1. So you have the log, the natural log of 2 equals 6R. I know I'm going very fast. Are you following me?
Yeah.
Okay, I didn't lose you. You seem like you're getting this pretty well. Now, how do I solve for R?
Divide. Do I define the natural log of 2 first?
Calculator can do that. Natural
Okay.
log of 2, and then I divide that by 6, right?
Mm-hmm.
So R equals 0.1155. It said to the nearest tenth of a percent. So how do I convert this to a percent?
Would be would it be 12%?
They want the nearest tenth. So I write 11.6%.
Okay.
Because you remember how for a percent, you just move the decimal place over 2.
Mm-hmm.
And there you have it. Again, it's recording. So that's why I'm going kind of fast, because I know you have a lot of questions on here. Next question. When the outside air temperature is anything of that to that, the temperature in the enclosed vehicle climbs by 43 degrees in the first hour. The function blah models the temperature increase after X minutes. So this is my temperature increase after X minutes. Use the function to find the temperature increase to the nearest degree after 50 minutes. Well, that means 50 is X, and we plug 50 in. So F of 50, I'm plugging that in for X, is 13.4 ln of 50 minus 11.6. So just plug that into your calculator. 13.4 times the natural log of 50 minus 11.6. Just hit enter, and there you go, 40.82. So that's 41 is the nearest degree to find the temperature increase. So 41 degrees is how much it increased. Which, hold on. Oh yeah, that makes sense, because it would increase by 43 degrees in 1 hour, and that's a little bit less than an hour, right? 50 minutes.
Mm-hmm.
Got it? Now it says how long to the nearest minute. So they're trying to solve for what now?
X.
Trying to solve for X until the temperature increase is 50 degrees per minute. How long to the nearest minute until the temperature increase is 50 degrees Fahrenheit per minute? I don't get the question. How long to the nearest minute until the temperature increase is 50 degrees per minute? That question is worded very strangely.
Yeah, this one's confused me, like when I was looking at our review.
I think the wording is what's confusing me. So I think what they want, this is your f of x, basically.
Okay.
I don't think they worded it quite the way that they meant to, but I know what they want you to do. So we're going to plug in 50 for f of x, and we're going to solve this equation for x. That's what they want us to do.
Okay.
How long until the temperature increase? I don't think they mean the temperature increase is 50 per minute. I think they meant 50 degrees. They don't mean 50 degrees per minute. It's never increasing 50 degrees per minute. Right?
Yeah,
They mean how long until the temperature increases 50 degrees. So this is your formula. So to solve it, we're going to add 11x to, or 11.6 to both sides, right?
mm-hmm.
50 plus 11.6, then what?
Divide by 13.4.
Good. Divide by 13.4. So I'm going to get, so this is 61.6 equals 13.4 ln of x. And then 4.597 equals ln of x. And now what? So remember that trick I taught you? Convert it. This is log base e, right? So it's e to the 4.597 equals x.
Okay.
So all I do is take E, that's second ln, and I raise the answer to that, or I raise E to the answer, and that's my X. X equals 99.19 minutes.
Okay.
And they want it to the nearest minute, so that's 99 minutes. In 99 minutes, it's going to raise 50 degrees. So see how it's slowing down?
Yeah.
It's not going in a linear fashion. It's slowing down because it's a logarithmic equation. Logarithmic models are the inverse of exponentials. Kind of like COVID. When COVID hit, they talk about how the COVID, there's a, I don't know if you were old enough. Well, yeah, you were old enough. You remember how they were like, you've got to mask, we've got to stay indoors, we've got to quarantine because the hospitals can't handle the number of patients we have right now. So they
Yeah.
weren't talking about trying to stop people from getting it. People are going to get COVID. They were trying to stop the hospitals from being overwhelmed from the people because that makes it worse. And so they were talking about flattening the curve, right? So an exponential or logarithmic, it's actually called logistics. It has a logarithmic in it, but an exponential looks like this, but it doesn't do that. It doesn't keep going up exponentially. It starts exponentially and then it kind of levels off and then it comes back down. So they were talking about trying to flatten the curve because they didn't want this exponential growth to happen at the beginning. But once people build up immunity and stuff like that, that's when it kind of levels off. And that's why they knew that was going to happen eventually, but they were just trying to level it off. They were trying to stop this from happening. They were trying to make the steepness right here go down.
Mm-hmm.
And so how does that relate to this? This isn't logistics. This is logarithmic, but a logarithmic curve looks like this. It goes like this. So it levels off as it goes to the right, it levels off. So it's steep at first. In the first hour, it goes 43 degrees, but obviously it's not like you've got an oven on. It's not continuing to go up. The heat, eventually there's kind of a limit almost to the amount of heat that there will be in a car. It doesn't just like explode eventually. It kind of just levels off, and that's what they're talking about here. So that's why in 99 minutes you'd think, oh my gosh, it's going to be so hot. Well, it is pretty hot, but it only went up 10 more degrees,
Yeah.
or I'm sorry, 7 more degrees in the next 30 minutes, and that's because it's in this peak in this area right here. Does that make sense?
Yeah.
There's a little real life for you there. All right, I know we're out of time, but I'll do this one for you real quick. Okay. As the town gets smaller, the population of its high school decreased by that much per year. The senior class is that much now. In how many years will it have about 100 students? Write an exponential equation and then solve. All right, so when this happens, decreases by that much each year, that means the rate, here's how you do it. It's 1, that represents 100%, minus your rate, which is 0.06.
Okay.
So that means it's 0.94. That's your rate. And that's the rate. That's called a exponential decay. If it was exponential growth, remember it's x1 plus or minus r basically, raised to the t. That's exponential growth or decay. And you put your principal out here, your original amount. Usually they call that a sub 0, your original amount. So your amount is equal to your original amount times 1 plus or minus r. It would be plus if it was growth, it would be minus if it was decay, raised to the t. Got it?
Mm-hmm.
So it says the senior class is 160 students. So that's your original amount. How many years will it take? So t, I want to know the number of years for it to decrease to 100. I want to know when my amount is going to be 100. Right now it's 160 and it's decreasing by that much. So how many years is it going to take? So there's your equation. And then to solve it, divide both sides by 1600, or sorry, 160. Right? And then take the log of both sides. And that allows the t to come down. Remember this?
Yeah.
So here's your equation. And I'm not even going to simplify anything because I'll show you, you don't really need to. And then now divide to get t by itself. I'm going to divide. Remember, these are just numbers. That's some number and that's some number. So to get t by itself, I just divide by that.
Okay.
Log of 0.94. So you can actually wait until the very end and then just plug it all in carefully. So it's the log of 100 divided by 160 divided by the log of 0.94. And then hit enter. And there you go. T equals, right? Then solve. T equals 7.59. We'll call it 7.6. 7.6 years. So about 7.5 years, a little over 7.5 years. That make sense?
Mm-hmm.
And you can check that answer as well, like I said, by doing that store trick and plugging it back in. All right. Hopefully that helped. You have a test or quiz. Is it coming up tomorrow?
Yeah, I'll probably be making it up tomorrow.
You have a choice of when you want to take it.